learners, welcome back to another week and another virtual lesson with Miss Shepherd. I am so glad to be joining you via video today to be reviewing a topic that I think we are going to be so strong in this week. It is lesson 20 from your packet. It's about fractions as tenths and hundredths. But first, you know the drill. If you don't have a paper, if you don't have the packet in front of you, or you don't have paper and pencil, pause this video and go and get that stuff and bring it back so we can have the best time learning together. Well, hopefully you've gone and done that. You've got your packet or you've got your paper and pencil in front of you and you are ready to go. So, just like I like to do every week, I want us to first review and revisit our prerequisite skill that we need to have an understanding of in order to be successful in today's lesson. And that prerequisite skill is that we can identify equivalent fractions. And just like every other week, we already learned this. You guys can do this. You already know how to do it. And I believe that we'll have the best success on this lesson together. So let's do a quick vocabulary review. So if you are looking at your paper right at the bottom of page 211 of lesson 20, it reminds us of what an equivalent fraction is. Let's go ahead and read that together. It says equivalent fractions. Two or more fractions that name the same part of the whole. Two or more fractions that name the same part of a whole. And I love the example that they give up here. The example they give are the equivalent fraction relationships between fourths, sixths, and twelfths on a number line. We know that number lines are a great way for us to see the equivalency between fractions. Now, it's been a while since we've used a number line to find equivalent fractions, so I wanted to just go ahead and work through our first problem together, being number 1. And it's where we're going to look at the number lines in the example above and write each equivalent fraction. Our first fraction that we're finding an equivalent fraction for is 8/12. Now, which number line do you think I'm going to go to find 8/12? Well, hopefully you said the 12ths number line. So I'm going to go there and I'm going to look and I'm going to go 1, 12, 2, 12, 3, 12, 4, 12, 8/12. Okay, so now I'm at 8/12. What do I do from here? Well, to see the equivalent fraction that is equivalent to 8/12, I'm going to just I could take my pencil or a straight edge or my finger and I'm going to go straight up and I'm going to see that 4/6 is equivalent to 8/12. I look and I don't see that there's any fourths that are equivalent to 8/12, but I do see that 4/6 is. So I'm going to go ahead and I'm going to write right next to 8/12 that 8/12 is equivalent to 4/6. 8/12 is equivalent to 4/6. Now, let's move on. That one you probably are like, Miss Shepherd, this was so easy, and that's great. Let's do one more together just to be sure. So the next fraction we're going to be finding equivalent fractions for is 2/6. 2/6. So which number line am I going to go to? The 6th. So I'm going to go to my 6th number line, and then I see 0, 1, 6, 2, 6. Okay. If I go straight up, I see that there's not an equivalent fraction between 2/6 and the fourths. But when I drag my cursor down and I see that 2/6 is actually equivalent to 4/12. 4/12. So I'm going to go ahead and write next to 2/6 that 2/6 is equal to 4/12. Now I'm going to leave you to do 3/12 and 1/6 on your own, but please send me your answers and I'm excited to see what you guys get. So that was just a quick review of how we can use equivalent fractions on a number line. Let's go ahead and scroll down to page 212, and I want us to look at number 4. Number 4, this is another way we can model equivalent fractions. So it says that first we need to shade the model below to show 2/3. I know if I'm going to shade to show 2/3, I'm going to go ahead and have to shade in 2 of these. Ooh, Miss Shepherd's shading job's a little off today. Sorry. But I'm going to have to shade in 2 of these parts. So I have 2/3 represented right here. Now it says that I'm going to divide it to show and to model 2/3 is equivalent or equal to 4/6. Now, I want you to pause the video right here and I want you to divide the model and I want you to show me how you got it. So go ahead and pause. Now, I want to let you know something. There's actually 2 different ways that you could have divided this model to show 2/3 is equal to 4/6. One way is you could have divided each of these parts in half, just like this. And you will see that now you have 1, 2, 3, 4 parts shaded, and 1, 2, 3, 4, 5, 6 parts in total. So 4 shaded out of 6 parts in total, and that shows 4/6. But maybe you're saying, Miss Shepherd, when I paused the video and I divided my model, that's not what I got, or that's not how mine looked, and that's okay. My guess is that you probably divided it in half. I remember in class, we always like to divide things kind of just in half. So when I take a look at this, I see that this shows the exact same thing as the other way. It shows that there are 1, 2, 3, 4 parts shaded out of 1, 2, 3, 4, 5, 6 parts in total. So let's go ahead and talk about this though, because it's important that we can explain what happened. So number 5 is a challenge question that I want us to do together, where we're going to explain how when we divided that model, it showed the equivalent fractions. So one possible explanation that we could say is when we divided the model, we have twice as many equal parts as twice as many shaded parts. It's the same thing when we find the equivalent fraction. Like if we were to find the equivalent fraction through multiplication, we would multiply 2/3 times 2/2, and let's go ahead and do that multiplication real quick just to make sure we're right. 2 times 2 is 4, and 3 times 2 is 6. Now I still want you to write your explanation here, but it's just a reminder that it's the same as multiplying the numerator and denominator, by 2/2, which gives us 4/6. So hopefully that was a good little review about finding equivalent fractions. Now we're going to get to the part of our lesson which is about the relationship between tenths and hundredths fractions. Now we spend so much time on learning about tenths and hundredths fractions and their equivalency to each other. They give a great example here about this problem about Jaden and the money he has in his backpack, and I recommend you read through that and go through it. It is so helpful. But what I want us to do is I want us to remember that the tenths and the hundredths, they all have equivalent fractions to each other. And so let's do a quick fluency with each other. I remember that 1/10 is equivalent to 10 hundredths. I remember that 2/10 is equivalent to 20 hundredths. 3/10, 30 hundredths. 4/10, 40 hundredths. 5/10, 50 hundredths. 6/10, 60 hundredths. 7/10, 70 hundredths. 8/10, 80 hundredths. 9/10, 90 hundredths. 10/10, 100 hundredths, which we know is equivalent to 1 whole. So hopefully that was just a good little reminder for you about the equivalent relationship between tenths and hundredths. And now what I would like us to do is I would like us to scroll down to this problem. It is on page 214 and it is a word problem, and we are going to learn about Mila. So let's read this together. Mila has 100 math problems. If I'm going to be doing cubes on this problem, I should be circling 100. It says Mila has 100 math problems to finish this week. She solved 2/10 of the problems, okay, on Monday, and 25 hundredths of the problems on Tuesday. Okay, so I now know that she has solved 2/10 problems on Monday and 25 hundredths of the problem on Tuesday. But what exactly is this question asking us? It says, did Mila solve more problems on Monday or more problems on Tuesday? Well, then it says explain and show your work. Well, first of all, what do we know and what do we not know? We know that she had 100 math problems to finish this week. We know that she solved 2/10 on Monday. So I'm going to just go ahead and show my work, and I'm going to put Monday, just a little M for that, and I'm going to put 2/10. And then I know that over here, I'm going to leave some room. I know that on Tuesday, it said she solved 25 hundredths. Okay, 25 hundredths. What do I notice right away? What do I notice right away? I'm going to think about this. Pause, think. Okay, hopefully you notice that 2/10 and 25 hundredths. I've got two different denominators I'm working with here. So it's going to be hard for me unless I change 2/10 to an equivalent fraction with a denominator of hundredths. It's going to be difficult for me to compare these two fractions to see if she did more work on Monday or if she did more work on Tuesday. So in order to solve, I'm going to need to remember what is 2/10 equivalent to in hundredths. Well, if you just rewind this video, I just reviewed it with you, and I remember that 2/10 is equivalent to 20 hundredths. 20 hundredths. So I'm going to just put the equal sign here, and I'm going to rewrite this as 20 hundredths. Okay. Whoopsie. Now it is so easy for me to see. Right here, I see that on Monday, she solved 20 out of the 100 problems, and then on Tuesday, she solved 25 out of the 100 problems. So that means that obviously 25 is greater than 20. So if I were to write in a complete sentence, because I am a college-ready scholar who is ready to write in a complete sentence, I am going to write that Mila solved more problems on Tuesday than on Monday because 25 is greater than 20. Now you might have a different explanation, or you might want to explain how you took 2/10 and made it into 20 hundredths, and that is great. Remember, we always want to explain our thinking and show our work. So that is just a quick little review on solving a problem where we have tenths and hundredths. Now, before I go for this video, I want to challenge you with some problems that I think that you could do because you're going to be so successful. So the first problem I'm going to challenge you to do, obviously you're going to do all of them, but I really want you to press into is number 2. Number 2 on page 215, and I really would like to see your work and to hear how did he get that answer and explaining to me how he got that answer. And then, once you've done all these, the last one that I really, really, really want you to do. Now, this is a challenge problem. This is going to push your thinking, and it's going to make you really have to explain how you got your answer is number 6, and it's about Owen and some presents and how he uses that money. And so I'm excited to see your solutions and your work. I know that you can do this. You guys have a firm foundation in equivalent fractions, and you know the relationships between tenths and hundredths. I'm excited to join you guys next week for another lesson. Again, please reach out for any other questions, and I hope you are having a great week.